Look at functions, but before that we're going to look at some mappings. Okay, so here we have some cities, and here we have some countries. And let's just see which cities map onto which countries. Well, London is in England, so that maps on to there. New York is in the USA, so that maps onto there. Manchester also is in England, so that maps onto there. Paris, we're going to map onto France, because that's where it is. Chicago in the USA, Marseille in France, and Detroit in the USA. So, with these mappings we can see what we have is a many, because lots of things are mapping onto one. So we have a many to one mapping. Now in this one we're going to take all the values in this box, we're going to call them x, and we're going to map them onto the values which are 5x plus 2. So 5 times x value plus 2. If x is 1, times by 5 gives you 5, plus 2 gives you 7. 2 will go to 12 and 3 will go to 17. So here we have what we call a 1 to 1 mapping. And here we have planets, and we're going to map them with their moons. So Earth maps onto the moon, Mars onto Phobos and Deimos, and Jupiter to Io, Ganymede, Europa, and so on. And here we've got what we have a 1 to many mapping. Only 2 of these can be functions, only 2 of these types of mappings. You need to know what you're going to get out for every value you put in. So here we do know what all of these will map onto. We know London always maps onto England. So this is a function. We can tick that one. All of these map onto all, we know what these are all going to map onto. So again, one-to-ones also functions. But when you have one-to-many, we're not sure which is going to be the right answer. You've got more than one possible answer for any one of the mappings. So this is not a function. We work with functions where we know what we're going to get out. And everything in the domain must have a mapping. Now you just heard me use the word domain. Now domain of a function is where we start. So the domain is all these values here. And the range, let me just choose a different colour so we can just see it more easily. Alright, the range will be all these values. This is our range. It's where we finish. Okay. Now this all looks a bit confusing. Seeing these blocks of things and thinking, how does this really relate to the maths we're going to do? Maybe it might be easier to see what a function really is. The function is how we get from the domain to the range. So we would use the function and we would give it a name, and in this case I'm going to call it f, and f tells me how I get from here to here. So this would be the function f would be how I map from x to 5x plus 2. Let's look at some simple functions. We're using some function machines. We'll get some machines to create some functions for us. And if you go to the Enrich website, okay, it's Enrich, spelled N-R-I-C-H .maths.org, you can find this function machine builder. So we're going to start off with something to give us an input. Then we're going to create something that's going to happen to that input. I'm going to add 2 to every input. So from that input, we put the input into the machine adds 2, and then we're going to get an output. Okay, so this whole machine is going to be called G. That's the name of the function. G is such that x goes to a new value. X started up here, and it became a new value down here. And let's put some values in. So let's put -3 in, add 2, we get -1. Let's look at the results table as we're doing this. Oops, let's just clear that, and let's just start again from another value. Let's start at -2 this time. So we get 0, we get -1, put it in, we'll get 1, because you're adding on 2, put 0 in, put 1 in, try again, put 1 in, and we get 3, obviously, adding on 2, put 2 in. So it's a very simple function here. We're adding on 2 and we get a result out. Now we've got a few results and we can actually do a plot of this. Now hopefully you'd have spotted what type of graph we got. So let's see if you were right. I'm going to hide the output stage so we can see the plots. And here, and actually probably hide the operation so we can see the plots better. This one and this one I forgot to clear from our previous graph, so it's a different one. These are all the outputs we just got here, and as you can see they're on a straight line. Okay, so we get a straight line function. We can see every value we put in gets a value out. Okay, we got a 1-to-1 mapping from this line. So let's just clear all of that and then just look at what this means for us. So let's look at what we had. We had our input, we added 2, and we got our output. Now if our input is called x and we add 2 to that, our output will be x plus 2. Now we gave this function a name. We called it g. So g is such that, these two dots mean such that x goes to a new value, and the new value of x is x plus 2. So that is our function. Now the input, okay, the mathematical name for that is domain. So if you think of domain as your input and think of your output as your range, alright, these are the mathematical names for input and for your output. Now if you remember our plot, if we were to draw them on a set of axes, we would get a line like this. Obviously at 0 we'd cross at 2, and here we're going to cross at -2, gives us 0. So this is our graph g of x. Okay, we've drawn y value equal to g of x if you get your x values and your y values. Now your y value is equal to your output, so the y values are the range. So let's just write that in red. So the range is here. We can look at the y values as being the range. Alright, let's put some blue on this for the domain. And the domain is what we put in. And those are our x values. So we can see that all our x values can be put into this graph. Right, all the way in there. And then for every x value we get out a y value. So we have a function, we have a 1-to-1 mapping function, and each one maps onto a unique function. So this is what we call a 1-to-1 mapping. Now let's look at another function machine. Let's get some new ones. We'll leave that there. Let's just change this a bit. Right, what I'm going to do is I'm going to just clear all of that. For some reason it doesn't want to clear these two old values. We'll just leave them there for now. And we're going to clear this results table and look at our operations. I'm going to use one of these, and I'm going to use one of these because I'm going to mimic a certain type of function. Actually, I'm not going to use one of those. I'm going to delete that. I'm going to have this also go into here. So I'm going to times this input by itself. So times the input by the input and get an output. So what do you think? Think to yourself what sort of function that's going to be. So let's put -2 in, and we can get our results table while we're doing this. And we'll put -1 in. -1 times -1 gives me 1. 0 times by 0 will give me 0, and so on. And hopefully you'd have spotted I'm squaring it. I'm timesing all the numbers by themselves. So this function machine squares the function. Okay, and we can see all these numbers coming out of square numbers. If we look at the plot, hopefully you know what the shape of the graph is you're going to get. Think to yourself, what shape are we going to get? and you can see this is the shape we get. Look at the blue ones, ignore the diamonds which don't seem to want to disappear off here. The blue ones gives a U-shaped graph, okay, our x squared graph. Okay, now we've got here, a many to one mapping, because more than one mapping will get the same answer. But it's still a function, because we can still get we know that each thing in our domain will map on to a value. We know we're going to get an answer out. So let's just look at that using our mathematical language.